THWN wire is not suitable for applications in kilns where the operating temperatures reach 160 to 180 degrees Fahrenheit. THWN insulation is rated for operating temperatures up to 90 degrees Celsius, which is equal to 194 degrees Fahrenheit. At temperatures above this rating, the insulation can degrade and become brittle, leading to potential failures. If THWN is used in high-temperature kilns, several consequences can occur. Firstly, the THWN insulation will break down over time. This breakdown leads to exposed conductors and an increased risk of electrical failures. Secondly, degraded insulation can allow current to leak between conductors. This leakage causes short circuits and potential fires. Thirdly, failed wiring can damage the fans and other electrical equipment in the kilns. It is important to select wiring that is rated for the operating temperatures within the kiln environment. For applications with operating temperatures exceeding 90 degrees Celsius, use high-temperature wire. Examples of suitable alternatives include MV105, which is rated for temperatures up to 105 degrees Celsius, and THWN, which is also rated for temperatures up to 90 degrees Celsius, but has thicker insulation for improved durability. When selecting wiring for high-temperature environments, several factors need to be considered to ensure safety and reliability. These factors include firstly the maximum operating temperature of the environment. This is critical to ensure that the selected wire's temperature rating exceeds the maximum temperature the wire will be exposed to. Secondly, consider the ampacity requirements. The wire must be sized appropriately to handle the electrical current required by the connected equipment without overheating. Consult the National Electrical Code, NEC, Table 310.15 P16 and related sections for guidance on ampacity calculations and adjustments for ambient temperature. Thirdly, select the appropriate insulation type. Different insulation materials have varying temperature ratings and resistance to environmental factors like moisture and chemicals. Choose an insulation type that is suitable for the specific conditions of the kiln environment. Fourthly, ensure compliance with codes and standards. All wiring installations must comply with the relevant electrical codes and standards such as the NEC to ensure safety and proper installation practices. This includes proper grounding, overcurrent protection, and wiring methods. The NEC provides detailed requirements for wiring in various environments, including those with high temperatures. Understanding and adhering to these requirements is crucial for preventing electrical hazards and ensuring the long-term reliability of the electrical system. Proper installation techniques are also essential for high-temperature wiring installations. This includes using appropriate connectors and terminations that are rated for the wire type and temperature. Avoid overstripping the insulation, which can expose the conductor and create a potential point of failure. Use proper torque specifications when tightening connections to ensure a secure and reliable connection. Regularly inspect the wiring and connections for signs of damage or degradation. Look for cracks, discoloration, or brittleness in the insulation, as well as loose or corroded connections. Any signs of damage should be addressed promptly to prevent electrical failures. Remember that using the wrong type of wire in high-temperature applications can have serious consequences. The degradation of insulation can lead to short circuits, ground faults, and electrical fires. These hazards can not only damage equipment, but also pose a significant risk to personnel. Therefore, it is crucial to prioritize safety and use the correct type of wire for the specific application. Choosing the right type of high-temperature wire will depend on the specific operating conditions and requirements of the kiln environment. Consider the maximum operating temperature, ampacity requirements, insulation type, and applicable codes and standards when making your selection. Consult with a qualified electrician or electrical engineer to ensure that you are making the best choice for your application. High-temperature wire such as MV105 offers superior heat resistance and is designed to withstand continuous exposure to high temperatures without degrading. The insulation is typically made of materials that are specifically formulated to maintain their electrical and mechanical properties at elevated temperatures. This ensures that the wire will provide reliable performance over an extended period. THWN wire is a versatile and commonly used type of building wire. While it is rated for temperatures up to 90 degrees Celsius, it also has a nylon jacket that provides additional protection against abrasion, moisture, and chemicals. This makes it a good choice for applications where the wire may be exposed to harsh conditions. However, it is important to note that THWN is still limited to a maximum operating temperature of 90 degrees Celsius and may not be suitable for extremely high temperature environments. When installing high-temperature wire, it is important to follow the manufacturer's instructions and use appropriate installation techniques. This includes using the correct type of connectors and terminations, as well as ensuring that the wire is properly supported and protected from damage. Avoid bending the wire too sharply, as this can damage the insulation and reduce its ability to withstand high temperatures. Also, be sure to provide adequate ventilation around the wire to prevent heat buildup. Regular maintenance and inspection of high-temperature wiring are essential for ensuring its continued reliability and safety. This includes visually inspecting the wire for signs of damage or degradation, as well as testing the insulation resistance to ensure that it is still within acceptable limits. Any damaged or degraded wire should be replaced immediately to prevent electrical hazards. In addition to selecting the right type of wire, it is also important to consider other factors that can affect the performance of electrical systems in high-temperature environments. This includes the design of the electrical enclosure, the ventilation system, and the overall heat management strategy. Electrical enclosures should be designed to provide adequate protection for the wiring and components inside, while also allowing for proper ventilation. Ventilation systems should be designed to remove heat from the enclosure and maintain a safe operating temperature. A comprehensive heat management strategy should consider all sources of heat within the environment and implement measures to mitigate their impact on the electrical system. By carefully considering all of these factors, it is possible to design and install electrical systems that can operate safely and reliably in high-temperature environments. Remember that safety should always be the top priority when working with electricity, and it is essential to consult with qualified professionals to ensure that all work is performed in accordance with applicable codes and standards. In the specific case of wiring kilns, it is important to understand the unique challenges posed by this environment. Kilns are typically used to dry or cure materials, and they can generate high levels of heat and humidity. This can create a harsh environment for electrical wiring, and it is essential to select materials and installation methods that are specifically designed to withstand these conditions. In addition to high-temperature wire, it may also be necessary to use other specialized components such as high-temperature connectors, conduit, and enclosures. These components are designed to maintain their integrity and performance in high-temperature environments, ensuring that the electrical system remains safe and reliable. It is also important to consider the potential for corrosive substances to be present in the kiln environment. Some materials that are processed in kilns can release corrosive fumes or vapors that can damage electrical wiring and components. In these cases, it may be necessary to use corrosion-resistant materials or to implement protective measures, such as sealing the wiring in conduit or using a corrosion-inhibiting coating. Proper grounding is also essential for electrical systems in kilns. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and equipment damage. The grounding system should be designed and installed in accordance with applicable codes and standards, and it should be regularly inspected to ensure that it is functioning properly. Regular inspections are important for identifying potential problems before they lead to failures. Look for signs of overheating, such as discoloration or melting of insulation, as well as signs of corrosion or damage. Any problems that are identified should be addressed promptly to prevent more serious issues from developing. If you are not comfortable performing electrical work yourself, it is always best to consult with a qualified electrician. Electricians have the training and experience necessary to safely and effectively install and maintain electrical systems in kilns and other high-temperature environments. They can also help you to select the right materials and installation methods for your specific application. When working with electricity, always remember to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing the circuit before performing any work. Never work on live electrical equipment unless you are specifically trained and authorized to do so. By following safe work practices and consulting with qualified professionals, you can help to ensure that electrical systems in kilns and other high-temperature environments are safe and reliable. Remember that proper selection, installation, and maintenance of electrical wiring and components are essential for preventing electrical hazards and ensuring the long-term performance of the equipment. It is important to stay informed about the latest codes and standards, as well as best practices for electrical safety. This will help you to make informed decisions and ensure that all electrical work is performed in a safe and compliant manner. By taking these precautions, you can help to protect yourself, your employees, and your property from the risks associated with electricity. And by using the right materials and installation methods, you can ensure that your electrical systems will operate safely and reliably for many years to come.